Okay, let's see what you can do with this one. I want you to write down f of x equals 1 minus x if x is less than or equal to 2, and 2 plus x if x is greater than 2. And then what I want you to do is set up your two t tables. And then turn off the video and see if you can fill in your t-tables and do your graph. And then you can start the video again and we'll see if we agree. Okay, so remember that the first number in both tables is that number there. Well, in this case, it's a 2. Now we need to choose a number less than or equal to 2, so I'll just choose a 1. And then I need to choose a number for this one greater than 2. I'll choose a 3. Now I'll plug those numbers into my formula. 1 minus 2 is negative 1. 1 minus 1 is 0. So I'm going to graph the point 2, negative 1 with a closed circle because that says less than or equal to. And then I'll graph the point 1, 0. And I'm going to draw a line starting at the 2, negative 1 going through the 1, 0. That would be all of the points less than 2 because the line x equal 2 is right here. Okay, so on the second equation, 2 plus 2 is 4, and 2 plus 3 is 5, but at the 2, 4, I need to have an open circle because this says greater than 2, not greater than or equal to. So I'll go over to 2, 4, and I'll make a point. Then I'll go to 3, 5. And I will draw my half of my graph that is to the right of the line x equal 2. And that's your piecewise function for that one. Now, what is our domain in this function? And if we're talking about all numbers less than or equal to 2 and all numbers greater than 2, there are no x's in there that are eliminated or skipped. So our domain is minus infinity to infinity. Okay, let's start out with this last example by answering these questions right here. So here's my function. F of x equals x minus 2 if x is less than or equal to 1, and x squared if x is greater than 1. So what would f of 5 be? Is 5 less than or equal to 1, or is 5 greater than 1? Well, 5 is greater than 1, therefore we're going to use the second equation, which says x squared. F of 5 is 25. Now what about f of negative 4? Negative 4 is less than 1, so we're going to use our top equation and put a negative 4 in for x, and we get negative 6. Now looking at this, we notice that we are talking about all x's. All the x's less than or equal to 1 and all the x's greater than 1. Therefore, our domain on this one is also all real numbers. Let's make our tables. And what number are we going to use first in each table? We are going to use the number 1. In this first one, x must be less than or equal to 1. So I'll use a number smaller than 1. I'll use the number 0. Let's plug those in. 1 minus 2 is -1. 0 minus 2 is -2. So I will plot both of those points and draw a line from my 1, -1 through my 0, -2. Now, this is a different equation. It's not linear. We should know by now that that's a quadratic equation, so it kind of curves. Y equals x squared looks like that if you do the whole thing, but we're only going to do a portion of it. We're only going to do the portion where x is greater than 1. So let's choose 1. 1 squared is 1. And choose a number greater than 1. I'll choose 2. And 2 squared is 4. Now at the 1, 1, I need to have an open circle because this says greater than 1. So 1, 1, and then 2, 4, and then remember it kind of curves, so we'll just draw it as a curve. Now if you have an open circle on a piecewise function, you will only have one. So don't try to put more than one open circle on these. And the open circle only occurs on the first point where you have a greater than or where you have a less than without the little line below it.